There are different types of electronic effect. One is inductive effect, mesomeric effect, resonance effect, hyperconjugation, and electromeric effect. Today we are going to discuss inductive effect. So let's try to understand what is an inductive effect. Inductive effect is the polarization of sigma bond due to electron withdrawing or donating nature of the functional group or atom. For example, in this molecule, here chlorine is the functional group. So we can number this hydrocarbon chain from the right direction. So this will be carbon 1, 2, 3 and this is carbon 4. When you compare the electronegativity of carbon and chlorine, you will see chlorine is more electronegative as compared to carbon. So it will withdraw electron density from carbon 1 and as a result of it, carbon 1 will develop partial positive charge. Now this partial positive carbon 1 will withdraw electron density from carbon 2 and as a result of it, carbon 2 will develop double delta positive charge. Similarly, this delta positive carbon 2 will withdraw electron density from carbon 3 and now this carbon 3 will develop triple delta positive charge, that is even less than the double delta positive. Similarly, carbon 3 will withdraw electron density from carbon 4 and now this carbon 4 will develop quadruple delta positive charge. Inductive effect is a permanent effect and it transmitted through single bond as you just have seen here. It diminishes on increasing the distance from the carbon. Carbon 1 will experience more inductive effect from chlorine as compared to carbon 4. Now come to the types of inductive effect. There are two types of inductive effect. First one is positive inductive effect and second one is negative inductive effect. Positive inductive effect is denoted by plus I and it is electron releasing effect, while negative inductive effect is denoted by minus I and it is electron withdrawing effect. We are going to discuss each of them separately. Now come to negative inductive effect. Let's consider the same example that we just have discussed. Here this chlorine being more electronegative, so it will withdraw electron density from carbon 1. And this carbon 1 will develop delta positive charge. In negative inductive effect, functional group withdraws electron density from neighboring carbon and as a result of it, carbon develops partial positive charge. And beyond third carbon, it has no significance. Means carbon 2 and carbon 3 will experience some of the inductive effect from the chlorine, but carbon 4 doesn't experience that much inductive effect from chlorine. So it becomes insignificant for carbon 4. Now come to the applications of negative inductive effect. Negative inductive effect stabilizes anion and therefore it decides the strength of an acid. Let's compare the stability of following anions. So let's examine the first anion. Here electronegative chlorine will withdraw electron density from carbon 1 and as a result of it carbon 1 will develop partial positive charge. Now this carbon 1 will withdraw electron density from carbon 2 and as a result of it carbon 2 will develop double delta positive charge. Now this carbon 2 will withdraw electron density from O negative. And that's how minus I effect of chlorine help to reduce negative charge over oxygen and thus stabilizes the anion. Now examine the second anion. Here chlorine present at the distance and it will withdraw electron density from carbon 1. Carbon 1 will withdraw electron density from carbon 2 and this carbon 2 will withdraw electron density from carbon 3. And now this carbon 3 will withdraw electron density from O negative. Inductive effect decreases on increasing the distance from the electron withdrawing group. In anion 1, electron withdrawing chlorine is present near to the O negative ion, while in case of second anion, electron withdrawing chlorine is present at the distance from O negative. That's why minus I effect is more enhanced in case of first anion, while it is weak in case of second anion. That's why first anion is more stable as compared to second anion. Now compare the stability of following anion. First we will examine second anion. In second anion, electron withdrawing chlorine is present, which will withdraw electron density from carbon 1 and it will withdraw electron density from carbon 2 and finally this carbon 2 will withdraw electron density from O negative. and minus I effect of chlorine stabilizes this anion. Now examine first anion. There are two chlorines. They both withdraw electron density from carbon, and this carbon will withdraw electron density from the next carbon, and finally it will withdraw electron density from O negative. They will withdraw electron density from O negative more effectively. Now examine third anion. There is no electron withdrawing group attached to the carbon. Minus I effect withdraws electron density, hence it stabilizes anion. As in third anion there is no electron withdrawing group, this will be least stable, and in first anion there are two electron withdrawing groups present. Inductive effect increases on increasing the number of electron withdrawing group. So first anion will be most stable, then the second one, and third one will be the least stable anion. Now let's see how inductive effect affect the acidic strength of an acid. It is acetic acid. When it reacts with water, it loses its proton. After losing the proton, it will form acetate ion and H3O plus ion will be formed. According to Bronsted-Lowry acid-base theory, this is an acid, so after losing the proton, it will form its conjugate base, and stable the conjugate base, stronger will be the acid. Inductive effect stabilizes the conjugate base or anion, hence it increases the acidic strength of an acid. So let's take one more example. Here it is acetic acid and this is chlorine substituted acetic acid. So now compare the acidic strength of both the acid. After losing a proton, acetic acid will form acetate ion, and here there is no electron withdrawing group attached to it. But when this chlorine substituted acetic acid loses proton and it forms this anion. Here minus I effect of chlorine stabilizes this anion as we just have discussed. Chlorine substituted anion is more stable, so the chlorine substituted acid will be more acidic. Now compare the acidic strength of following acids. First one is chlorine substituted acetic acid and the second one is fluorine substituted acetic acid. When it loses one proton, it will form this anion and this anion is stabilized by the minus I effect of chlorine. And in case of fluorine substituted acetic acid, this anion is stabilized by the minus I effect of fluorine. Fluorine is more electronegative as compared to chlorine. Minus I effect increases on increasing the electronegativity of functional group. So in case of fluorine is more electronegative, so this anion will be more stable as compared to chlorine substituted anion. So the fluorine substituted acid will be more acidic as compared to chlorine substituted acetic acid. Here is the list of functional group in their decreasing order of minus I effect as compared to hydrogen. Now come to the positive inductive effect. There is a donation of electron density to the neighboring carbon. For example, in this carbocation, this alkyl group donates electron density to the carbon and as a result of it, this carbon will develop delta negative charge. And as a result of it, positive charge reduces over this carbocation. That's why it stabilizes cations. Here is the list of functional group in decreasing order of plus I effect. Tertiary alkyl group shows maximum plus I effect, then secondary alkyl group, then primary alkyl group, then methyl, and hydrogen shows the least plus I effect. Or you can write it in this way also. Here this carbon is tertiary carbon, this carbon is secondary carbon, here this is the primary carbon, and this is methyl and this is hydrogen. So let's compare the stability of following cations. Here first identify the cation. This cation is primary cation, this one is secondary carbocation, and this is the tertiary carbocation. In primary carbocation, this alkyl group shows plus I effect and stabilizes this carbocation. In secondary carbocation, there are two methyl groups that donate electron density through plus I effect. Tertiary carbocation, there are three methyl groups that donates electron density via plus I effect. Because there is more plus I effect in case of tertiary carbocation, it is the most stable carbocation. And primary carbocation is least stable carbocation because there is only one donating group. Or you can say inductive effect increases on increasing the number of electron donating groups. In tertiary carbocation, there are 3 electron donating groups, while in primary carbocation, there is 1 electron donating group. That's why tertiary carbocation is most stable. Primary carbocation is least stable among them.